Hi everybody, this is a demonstration of something that we can see that will hopefully tie in with the simulations we've been doing, and all the simulations are just exactly that. They're simulations of things that we can really never see. We can't see little particles the size of atoms and molecules moving around, and scientists never really have. So how did they figure out what they're doing? Well, they figured it out by the stuff that you can see. And so we're going to do some demonstrations we can see today and see how they relate to the simulations we've been doing that we cannot see. And the key on this is we're going to do some simulations. One involves only gases. This container is filled with nothing but gas. It's a closed system and it has a balloon on the top. This system is another closed system, and it is filled with nothing but water. The water is colored red just to make it easier to see what's going on. And then I've got this little system I'll get out in a moment, and this is a solid system, and it's really a closed system too because no atoms join in this solid, and none of them are going away as a liquid dripping off it or a gas going into the air. So what we want to do is we want to see how all of these states of matter respond to heat. And so what I'm going to do is I'm going to get my two beakers here, and I'm going to fill one up with very hot water. It's over here boiling. So on the right here where I've got my gloves is some very warm water. And then in this other beaker we are going to put some very cold water. This water has got ice cubes in it. And the first thing I'm going to do is put my closed system that has just air in it. And we'll put it in the hot water first, and I'm going to hold it down a little bit. And you can see there's a pretty immediate reaction with that. So remember, there's no more molecules in there. It's not like when we blow a balloon up with our mouth. When you blow a balloon up with your mouth, you're forcing more molecules into the balloon. That's like an open system. This is a closed system, and we can see now that those molecules have got to be taking up more space because the balloon has blown up. Same number of molecules, but they're behaving a little differently because they are now been heated. When I put it into the cold water, you can probably guess what's going to happen. All of a sudden, we get the opposite effect, and that balloon just immediately deflates and will actually deflate enough to almost crush itself. And all that's changing is the temperature of those molecules. And we've seen in our simulations a couple things that happen to the molecules in those simulations when we heat them and we cool them off. And with the gas, it's a pretty dramatic change pretty quickly. We get a pretty big volume change right off the bat with the gas. It changes a lot. Now the second one we want to do, we're going to use the same thing. I'm going to go ahead and recharge my hot water now that I got boiling water over here, just to make sure I've got the hottest water possible. And now I'm going to put it in my other closed system in here, which is this closed system that was filled with water. Now just to make it so we can track it with our eyes a little better, I've got this ring stand, and the ring stand is just about the height of the water right now, and that's so we can track it. So we'll go ahead and put this in, and we'll see what the effect is on that. Now you can already see the effect. It certainly isn't as dramatic as our balloon was. Our balloon filled that up and blew that balloon up almost right now, but you can see something very similar is happening right here with the water molecules. They don't do it as drastically as our gas molecules do, which is why we don't have any kind of, we don't use this kind of thing with it. If we just filled this with water and heated it up, your eye couldn't even pick up the movement. The reason it's picking up this movement so well is I've used a very thin tube on it, and that thin tube just makes it so we can see what's happening a little easier. And all of you guys have probably figured out already that this is exactly how a thermometer works. And the thermometer all has really small amounts of liquid in it in a really thin tube, because that way we can see a lot of movement in our thermometer. And you can see we've now had the water move from roughly here to here, and so that's very, very similar to what we saw with our first display that only used a gas. We had a liquid, just didn't do it quite as much. And this is going to take a while. We're not going to watch this whole thing, but we'll have it on there just so we maybe can come back to it in a second. We'll cool it off, and it's going to do the same thing that the balloon did, but it's going to take a moment. While we're waiting for that to happen, we're going to do our final demonstration. We've done a demonstration with a gas, a liquid. Now we want to do a demonstration with a solid. And this is, for obvious reasons, called a ball and ring assembly, and you buy it at a science store for geeks, and it is just to show this principle. And basically what you have is a brass ring and a brass ball, and the tolerances are really close. I can't wiggle that at all when it's inside that, but I can really easily move that back and forth off of it. So now I'm going to apply a little heat with Mr. Torch. This is a lot more fun when I can threaten to burn students in class. I'm going to go ahead and heat that up. Get it around like I'm roasting a metal marshmallow. Nice and warm. Now, unlike the gas, which we saw blow this balloon up, unlike the water, the liquid, which we could see come up this pipe, my guess is that ball doesn't look any bigger than before I heated it. Because what happened, remember, this does it less dramatically than this, a solid even less dramatically than a liquid, but I can't get that off, and I am trying. I can't get this over that ball unless I come over here and I cool it back off, and then it comes right out. So all three of these did something very similar. They didn't do it at the same rate. Gas the most dramatic. Liquid, we had to put it in a very small tube to be able to see it well. And this one, we had to have this ring that was just barely bigger than this so we could see it. Mechanics use this kind of strategy all the time when they're working on pretty much anything. So that's our demonstration today. Again, this is just a thing, something that you can see that is showing you why scientists know those particles are doing what they're doing that you see in all the simulations you've done. Okay? Thanks for watching.